Now we're going to do question 4. Okay, the question says in the diagram below, Q is the center of a circle at that intersects the y-axis at P and S, and the tangents APB at P intersects the x-axis at P, and makes the angle alpha with the positive x-axis. R is the point on the circle, and PRS equal to theta. All right. Now, the question 4.1 here says determine the equation of the circle in the form x minus a to the power of 2 plus open bracket y minus b all to the power of 2 equal to r squared. Okay, that's the formula. Okay, the formula for the equation of the circle. So how can we do that? Right here, we want the equation of the circle. Okay, the form x minus a to the power of 2 plus y minus b to the power of 2 equal to r squared. So what do we know from the equation here? We know that a and b stand for the coordinate of the circle. Okay, maybe okay, I'm gonna use so we do know that a and b are the coordinate of the center of the circle. Okay, and r here is just the radius. I'll leave it like that. Now, we can substitute the coordinate of the circle because the coordinate of the circle is given, the center of the circle is given, and it is 5 and 2. So we can substitute there. So this will be x minus a plus y minus b to the power of 2 equal to r squared. Okay, a is 5, the x coordinate, and then that's b is 2, the y coordinate. Then what else do we know from the equation? We know that the points, we have like points given in this, we have a point p is given. So this point, because it is a point on the circle, so we can substitute the coordinates of the points over here. So this will be minus, we substitute the coordinates x and y, r squared. We can sub in the value x here is 0, and then y is 6, and then we can calculate that makes negative 5 to the power of 2, which is 25, plus 4 to the power of 2, which is 16, equal to r squared, and 25 plus 16 makes 41. R squared is equal to 41. Therefore, we can write then this is x minus 5 to the power of 2 plus y minus 2 to the power of 2 equal to 41. So this is the equation of the circle in the form that was given. Okay, we can also solve the same problem by looking at, we can start working out the radius, okay? Because we have the radius. The radius is the point that connects the center to any point in the circumference in the circle. So the line, we have like, we can form lines like, let me draw a line here, QP. It is a radius. This is also a radius, QS. But QS will not really help me because I don't know the coordinate of S. But PQ, yes, we can find the distance. We find the length PQ by using the distance formula. Okay, we can say the distance formula, the distance between 2 points, we know is given by square root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. So in this case here, the distance is r. R will be square root of x2, let's say 0 minus x1 minus 5 to the power of 2 plus y2, which is 6 minus y2, y2 minus y1 to the power of 2, and then we get r equal to, if we work it out, it's square root of 41, which means that r squared equal to 41. Okay, then we can now right over here we can find the equation. You can see here, therefore, the the equation which is x minus a to the power of 2 plus y minus b to the power of 2 by substituting the coordinate to the center, which is 5 and 2, okay, equal to 41, equal to, this is equal to 41, okay, so that's the equation of the circle, okay, the two different ways we can solve the same problem. Then, so what the following question says, okay, I prefer to, because of space, I think I should have write this over here. So this will be x minus 5 to the power of 2 plus y minus 2 to the power of 2 equal to 41. Then the following question is, let's see, calculate the coordinates of S. S is this point over here. So how can we find the coordinate of this point S then? All right, I'm going to write the question over here. Yeah, let's move my board over here. Then split the board like this. Okay, now we're doing question 4.2. We're looking for the coordinate of S. Okay, it has an x and y coordinate. Now, let's first put the same diagram over here so we can see if you're like kind of. So now you see the diagram the same diagram. We're looking for S, the coordinate of S, but what we notice, S is a point on the circle, okay, and it's also a y-intercept, okay. So y-intercept means x is equal to 0. Over here, its x coordinate is 0, but its y coordinate is unknown. So we're going to substitute these coordinates in the equation of the circle, okay, because it is a point on the circle. So this will be x minus 5 to the power of 2 plus y minus 2, okay, y minus 2 equal to 41. Now let's sub in, x is equal to 0, okay, and then y equal to 6, and then this is what? Negative 5 to the power of 2, 0 minus 5 is negative 5 to the power of 2 is 25, okay, plus 6 minus 2 to the power of 2 is 16. Excuse me, over here, it's y. I meant to say, I wrote the wrong coordinate. I look at this one. So it's that other coordinate where y is just someone, y is here, and then this is just y minus 2 equal to 41. Now we can move the 25 over, so we have like y minus 2 to the power of 2 equal to 41 minus 25. And then this means this is equal to y minus 2 to the power of 2 equal to 16. Now, situation like this, we can expand and then solve by factorization, okay, but I prefer here to square root both sides. Okay, I will square root both sides because the square roots will cancel the power of 2. Square root over here, over there also. So this will make, because this square root will cancel the power of 2. Square root will cancel the power of 2, and then I am left with y minus 2 equal to, over here I write plus minus 4, okay? Remember that whenever you square root within an equation, we must always keep the positive and negative sign in front of the constant. I give you a clue. Let's say if I ask you what is negative 3 to the power of 2. Let me change the color here, and then I'll do somewhere here. If I ask you like negative 3 to the power of 2, you tell me this is equal to 9. If you press the way I just type in the calculator to get 9. What about 3 to the power of 2? 3 means positive 2 to the power of 2 is also 9. The reason why within the equation, we will always write plus or minus, okay, because this is negative, that's positive. So I write y minus 2 equals plus minus 4. And then if I move the negative 2 over, that makes 2 plus minus 4. And then I have like y equal to, here there are two answers, okay? 2 plus 4 equal to 6, or 2 minus 4 equal to negative 2. Now, by looking at the coordinates, by looking at the points S, you'll see that the point S is underneath the x-axis, meaning on the third, in the middle of the third and fourth quadrants. So this side, the y is negative, okay? It's below 0. The y is negative. So we can say this y minus 6 is not applicable, but the coordinate of S is negative 2. Okay, y here, therefore, then we can say, therefore, the S coordinates are like 0 and negative 2. Thank you. Now, let's see what else do we have. Question must be question 4.3. We'll go over here to see question 4.3. What's question 4.3 says? So we did 4.2. Now we need to do 4.3. The question says determine the equation of the tangents A, P, B in the form y equal to mx plus c. So the equation of the tangent A, P, B is this one. Okay, A, P, B. So in the form y equal to mx plus c, obviously because the tangent is always a straight line. Okay. I want to move my board over here. So we have let me split. So we will do now question 4.3. So we need to find the equation of the tangent APB, okay? Mx plus c over APB. All right. Let's just put the same diagram over here so we have a better understanding. So we want the equation of this line, the tangent line to the circle. How can we get that then? Okay, because we only have like one point given here, the point B. But there is a property that says in analytical geometry for tangent to the circle is that the radius is always perpendicular to the tangents. The radius, okay, is perpendicular to the tangents to the circle. So in other words, if we find the gradients of the points connecting Q, the center, and the points on the tangent, PQ. Okay, let's first do it. Let's first find the gradients of MP. So the gradients, as we know by definition, is the change of y's over the change of x. Okay, so now over here, the gradients of the line PQ will be 6 minus 2 over 0 minus 5. So this means the gradients MPQ is equal to negative 6 over 5. Obviously, the line is decreasing, so the gradient must be negative. Now, what else then? Now, we say that the two lines here are perpendicular, okay? So I'll say that MPQ is perpendicular to APB, okay? The reason is that radius and okay, radius and tangent line. Radius and tangent line are perpendicular. Now, if they're perpendicular, so we know the conditions, two lines are perpendicular if the products are equal to -1. So it means that, you know, M1 times M2 are perpendicular if the product is -1. This is the formula. But in short, what we can do, we can just swap the gradient of the other and then change the signs. If the sign was positive, we make it negative. If the sign is negative, we make it positive. Like in this case, we're going to make the sign positive and we will reverse the fraction, okay? So therefore, MAPB, APB equal to 5/6 and then positive then. This should be the gradient of MPB. All right, now we're going to substitute in the equation. So this makes y equal to 5/6 x plus c. Okay, now I can sub the points. The only point I can sub is the point P. Okay, the point P is 0, 6. So I'm going to sub the point, the coordinate of the point there, 0 for y, and then 0 for x and then 6 for y. So the point will be 6, 0 there. Anyway, in other case, C is always the y-intercept. Okay, we can just say plus 6 there because this 6 stands for the y-intercept. So, but let's just substitute the points because I already did it. 5/6 plus C. Okay, let's make 6 is equal to C. Now, therefore, the equation of the line or the tangent line APB is equal to 5/6 x plus 6. That's the equation of the tangent line. Good. Right now we're going to do 4.4. Let's see. Question 4.4. What does it say? Well, question 4.4 says, excuse me, it says calculate the size of alpha. So we can see that the angle alpha is this angle. Okay. We already know the equation of this line, so to find alpha will be easier because we can use the tangents. The current formula that says, okay, let me write the question here. We have like 4.4. So we need to find alpha. All right. Let's first draw the same diagram over here so we can visualize the equation very well. So we need to find alpha, and in the previous question we did find the equation of the line APB. Okay, it was 5/x plus 6. This one. Now I'm gonna write it here. Y equal to 5x plus 5/6 plus 5/6x plus 6. So we do know that the gradient, okay, by definition, that the gradient is equal to m equal to 10 of the angle. That by definition. So, or in other words, 10 of the angle equal to the gradient. So in this situation, we can just say 10 of alpha will be equal to 5/6. Okay, because we didn't get 5/6 over here. Now we can use our calculator to find alpha. Alpha then will be equal to 10 minus 1 over 5/6. Careful, this power of -1 here, this -1 here is not the exponent, it's not the power here. Just the way the calculator types the inverse function of 10. Okay, this simply means what angle alpha such that 10 of that angle equal to 5/6. So we'll do about the help of the calculator. Over here I can just shift, okay, press shift button, and then you look at 10 here. When you press 10, that's 10 minus 1, and then we can write excuse me, 5/6 there, and then close bracket, and then when we press equal, then we get alpha equal to it was 39.881. Okay, we look at the third decimal value, which is 5, then we can increase the second decimal value 0 by 1, so this will be 39.81. So 39.81 alpha. Okay. Now let's see. The last question is. Oh, it's not the last. Let's see. Is it the last? Oh, no, it wasn't the last question. Now we're doing a 4.5. That says calculate with reasons the value, the size of the angle theta. Angle theta is this angle. All right. Now, I'll move my book over here. So now right here, question 4.5. So we're looking for the angle theta, and then we need to provide reasons for that. All right, how can we get angle theta? Okay, one of the reasons is what we call the 10 chords. The 10 chords, I'm saying that because we have the tangent line over here. Okay, and then this, and we have also another line, PQ here, I mean PR, we have the line RS. So what we can say then, the angle theta, according to the codes, the 10 chord theorem, we will say that theta will be equal to the angle formed by the 10 and the y-axis. So it is equal to, theta will be equal to the angle BPO. Okay, so what's then angle BPO? Because this is alpha, and then the y-axis. Over here we have like a right angle triangle. So because it's perpendicular, the y-axis and x-axis. So now the angle by P here is the angle, we say 90 degrees minus alpha. Because this is alpha and this is 90 degrees, this must be 90 degrees minus alpha to have like some of the angle equal to 180 degrees. Maybe let me say it again. You know, according to 10 codes, let me write here. 10 code. Okay, so this theta will be equal to the angle BPO. So what is now the value of angle by P here, or the angle BPO? We already know that this angle is given to be alpha, and then this angle is 90 degrees, forming 90 degrees alpha, 90 degrees angle. Okay, the angle perpendiculars from the x and the y-axis. So now this is 90, and this is alpha. This angle must be 90 minus alpha to make a sum of the angle here equal to 180 degrees. So over here, this is like 90 degrees minus alpha. Now we can say theta will be 90 degrees minus alpha. Now in the previous question 4.5, we did find the value of angle alpha. Angle alpha was 39.81. Okay, so we will do okay, I think, oh yeah, the way it gets mistake somewhere here. Oh la la. Over here, in the question 4.3, 6 minus 2 equal to not negative 6/5, but negative 4/5. So there is 4/5. We need to correct that one. 4/5, and then that's 4/5. Okay, that will be then. Therefore, this will be 5/4. Okay, let me correct here. 5/4. 5/4. Positive 5/4. No, it's correct. Positive 5/4. And then this big, the x-intercept is still going to be 6. Okay, it is the x-intercept. I meant to say the y-intercept. It's still 6, so 6 there. So this is the correct answer. So over here we need to change. It's 5/4, not 5/6. 5/4. So 5/4 over here there. So now if we do in the calculator, then 10 over shift, we press the shift button, this button shift, and then we can hit 10 over 5/4. Okay, this is equal to 51.34. Okay, and then yeah, I stopped there because the third decimal value is just 0. So that's 51.34. You can correct one. That makes 51.34. So we can do now question 4.5 here. Theta will be equal to 90 degrees minus 51.34. And then this means that theta will be equal to, yeah, I can just do that in the calculator here. I will do minus 90 and then take the positive. So this will be equal to positive 38.67. Okay, I'm going to round up to the we look at the third decimal value, which is 9. So we increase the second decimal value 5 by 1 unit. So that makes 38.66. So 38.66. So this is the value of theta, the value of angle theta. Thank you. Well, another way of solving the same problem over here, if the 10 chord theorem is not don't really make sense, we can look at this. Okay, we have like this side is given. Okay, PS is given, and then Q is the center of the circle. Okay, so we can do this. Let me connect. We can do P. Okay. This and then work out the angle subtended. Excuse me. I mean, use the angle angle at the center. So, what can we do over here? We do know this and this are equal, okay? Because they're both the radius. The radius was found in the previous questions. It was 41, square root of 41, and that was the square root of 41. Now, you can say this angle theta, okay? And this, or let's call this angle, let's give it a name, any angle, alpha, beta, gamma, let's say gamma, angle gamma. Now, we know the distance PS here will be, because S was found, it was, over here the point was found to be -2. So we can look at the distance here, 6 to -2, so PS is equal to 8 units, okay? So we can say PS equal to 8 units. And then PQ equals to PS, and then they're both equal to root 41. Now we can use the cos rule because we don't know any angle. We only have the sides of 3 lines, so we can use the cos rule. The cos rule says A squared equal to B squared plus C squared minus 2AC times cos of the angle theta. Okay, so from there, why? Because we need to find the angle now. In this case, the angle is gamma. So we say I pick up any side. Okay, because this, I say this is PQ because okay, let's correct over here. The angle must be angle of E, opposite sides E. So this will be like PS will be equal to PS squared will be equal to PQ squared plus QS squared minus 2PQ times QS times cos of gamma, the new angle. So now PS squared is 8 squared equal to PQ squared must be 41 plus 41 minus 2 times 41. Okay, square root of 41 times 41 makes 41 times cos of the angle gamma. And 𝐻² is 64. 41 plus 41 makes 82 minus 82 cos gamma. So if you move the 82 over, we have like 64 minus 82 equal to negative 82 cos gamma. And then this 64 minus 82, this is equal to 18. Okay, negative 18 minus 82 cos gamma. And now we can divide both sides by negative 82. So this will be, so divide by negative 82 here and negative 82 over there. Okay, what we have, move my board over here. So let me just split it this way. So what we have, so we have like 18 over 82 equal to cos gamma. So cos gamma, which means that cos gamma equal to 18 over 32. 82. Now, if I need to find gamma, then the angle gamma, I'll say angle gamma will be cos minus 1 of 18 over 82. Then we can use a calculator. This time we press shift, the shift button over here, and then we press the cos button, and then we can write 18 over 82. Okay, close bracket, and this is equal to 77.32. Okay, so gamma equal to 77.32, as we can see over here. Now, I was saying we can then use angle at the center property. Okay, because angle at the center is half the angle at the circumference. So we can say therefore theta equal to a half gamma, because the reason is angle at the center. Angle at the center is equal to a half angle at the circumference. And then we can find theta equal to a half times 77.32, and then theta will be equal to, if we divide this by 2, because times a half is divided by 2, 38.67, exactly what we got over there, 38.66, I mean. So 38.66. Okay, so now let's see, this is a different way of solving that problem. Now let's see the other question over here, question 4.6. I guess the last question. Yes, this is the last question. Now we do question 4.6. Calculate the area of the triangle PQS. All right. The board over here to this question. So we want the area of the triangle PQS. Okay, I think I'll write it here. 4.6. We want the area of the triangle PQS. All right, I think I need to draw the same diagram over here. Okay, here's the diagram. Now we want the area of this triangle. Let's show it. PQS. Okay, this area, approximately. Now, we do know the base of this triangle is 8. First of all, we do know that this triangle is an isosceles triangle, because this is root 41 and that also root 41. Okay, So now the base here is 8, and then because the base lies on the y-axis, okay, we can also find the height, immediately find the height of this is just 5 units, because this is where 5 units is. So the distance from there to there is 5 units. How tall is 5 units? So we can just say the area, the area of the triangle is given by a half times base times height. Okay, so this can be written. This will be the area will be a half times the base, which is 8, and the height is 5, and then the area will be 20 units squared. So that's the area of the triangle. Thank you. Please give a thumbs up if you like it, and subscribe. Thank you. Bye.